Think you know Jupiter? Trust me, you don't. Not yet. For years, scientists were basically arguing like two friends who both swear they're right. One group said Jupiter had no core at all, just gas, all the way down. The other group said, no, it has a solid core. Rock, metal, heavy stuff. And then, in 2017, Juno showed up and said, yeah, you're both wrong.
Enter the void.
Join me for the next minutes. We're going deep into Jupiter, like really deep. Grab a drink, sit back, and let's figure this out together. Quick question for you. Up to this point, which side would you have been on? Team solid core or team no core? Let me know in the comments. What Juno revealed is honestly one of the weirdest things we've ever discovered about a planet. Jupiter does have a core, but it's not solid. It's not missing. It's fuzzy. A blurry, diluted, blended mess of heavy elements is lighter gas that takes up half the radius of the entire planet. And that one discovery, it forces us to rethink how Jupiter formed, what's happening inside it right now, and even how the hell its bizarre magnetic field works. So today, let's break this whole story down, but in a way that actually makes sense. 2 theories, 1 problem. Before Juno, scientists had 2 main explanations for how Jupiter came to be. 1. Gravitational collapse. This idea says Jupiter formed when a huge cloud of gas in the early solar system collapsed under its own gravity. Kind of like a star, but without getting hot enough to ignite. In this version, Jupiter wouldn't have a core at all, just gas, gas, and more gas. 2. Core accretion. This one feels more intuitive. A chunk of rock and ice forms first, pretty big, like 10 to 20 Earth masses. And that seed starts pulling hydrogen and helium toward it. This predicts a solid, well-defined core, surrounded by layers of gas. For decades, it was one theory versus the other. Team solid core versus Team no core. And then Juno said, actually, neither. If this is already making you rethink how planets form, tap like so YouTube knows to push more science content to people who never hear this stuff. The Planet X-ray Machine. Juno wasn't like previous missions. It didn't just take pictures. It basically X-rayed Jupiter using its gravity and magnetic field. It swooped just 4,200 kilometers over the cloud tops, super close. And every time it passed, it measured tiny changes in speed, like 0.01 millimeters per second. That's insane precision. Why gravity? Because gravity tells you where the mass is. And where the mass is tells you how the planet is built inside. If the interior were nice and uniform, Jupiter's gravity would look smooth. But it wasn't. Not at all. These little gravitational wiggles let scientists map Jupiter's insides in ridiculous detail. And that's when the surprise happened. Juno's data said, Jupiter does have heavier elements in the center, but there's no sharp boundary. The core gradually blends into the hydrogen above it, and the whole thing is huge, extending about halfway to the surface. Imagine taking a solid rock core and mixing it into a giant smoothie. That's Jupiter. It completely shattered both classic theories. So, how do you even make a fuzzy core? Was Jupiter hit by a planet? One idea scientists loved was that early Jupiter had a solid core, but something massive, like a mini-planet, smashed into it. The collision would have shattered the core and mixed the heavy elements into the surrounding gas. Cool idea. But there's a problem. Supercomputer simulations tried to recreate this scenario, and every time, the core got shaken up. The material mixed temporarily, but then it settled back down, like mud in water. The fuzzy core didn't stay fuzzy. It reformed into a solid blob again. So the collision theory, not impossible. But it doesn't fit the data. We needed a bigger clue. The answer comes from Saturn. In 2014, scientists studying Saturn's rings discovered something crazy. The waves in the rings are caused by vibrations inside Saturn itself, like listening to a planet's heartbeat through its rings. When they matched that with Cassini's gravitational data, Saturn appeared to have, guess what? A fuzzy core too, a huge one. Which gas giant is weirder, Jupiter or Saturn? And Saturn has large regions that don't convect, meaning the interior isn't mixing like soup. Heavy elements stay in the middle and slowly blend outward. Suddenly, it wasn't just Jupiter being weird. Gas giants in general might naturally form fuzzy cores. Not because of a single dramatic event, but because that's simply how they grow. Why fuzzy cores change everything? If giant planets form with fuzzy cores from the beginning, our models of planet formation are too simple. The cooling and evolution of gas giants works differently. Heavy elements don't stay in one place, they dissolve and spread. Boundaries inside planets aren't sharp, they're gradients. This messes with everything from exoplanet modeling to how we interpret mass, radius, and interior heat. Basically, fuzzy cores broke the old textbook. Now let's talk about the magnetic field. Jupiter's magnetic field is absurd. The strongest planetary field in the solar system. So big, it reaches Saturn's orbit. The standard explanation is a metallic hydrogen dynamo deep inside Jupiter. But here's the twist. A fuzzy core actually makes the magnetic field harder to explain. Why? Because magnetic fields rely on convection, fluid moving around and generating electric currents. But Jupiter, like Saturn, has large regions that don't convect. Scientists modeled how these stable layers would affect the magnetic field. The upper stable region makes sense, the lower fuzzy core region doesn't match reality, which means Jupiter's dynamo is more complicated than expected. There might be helium rain layers with different conductivity, asymmetric convection, or something we haven't even theorized yet. Bottom line, the magnetic field mystery is still wide open. But one thing is clear. Jupiter produces the biggest, brightest, most powerful auroras in the solar system. Way stronger than Earth's, and they never stop. Hubble even captured them in ultraviolet, and they look unreal. But behind that beauty is a planet whose interior is still confusing the hell out of us. We don't know how the fuzzy core formed, if it will stay that way forever, how it interacts with the metallic hydrogen, or what it means for exoplanets everywhere. Juno solved one mystery and created about 50 more, which, honestly, is the best part of science. The more answers we get, the more questions we uncover. We thought we knew Jupiter. We were completely wrong. Before you go, mark your calendar because next Sunday we're diving into another mind-bending space mystery that will completely change how you see the universe. Trust me, you do not want to miss this one. Hit that subscribe button and turn on notifications so you're here when we uncover the truth together. See you next Sunday for Space Sundays, where the cosmos gets real. Stay curious.